Hello students, welcome to Saurav's classes. The problem that we are going to solve today says consider the domain D equal to xy belong to R square such that x is less than equal to y and the function h from D to R defined by h of xy equal to x minus 2 to the 4 plus y minus 1 to the power 4. What we need to find is the minimum value of h on the set D. Now let us see the graph of D. Since this is the line y equal to x and we have to take y greater than equal to x, so it basically is this region including the line y equal to x, and we have the function from this to R. Now since it is x minus 2 to the power 4 plus y minus 1 to the power 4, in some sense we should actually think about what the midpoint of these two would be, where this fourth power would be equal to this fourth power. Now such a point I claim is x comma y equal to 3 by 2 comma 3 by 2. What happens at 3 by 2 comma 3 by 2? X minus 2 becomes minus half and y minus 1 becomes half. So this to the 4 plus this to the 4 becomes 2 by 16, which is 1 by 8. Now suppose x is equal to 3 by 2 plus delta, y equal to 3 by 2 plus epsilon. Delta and epsilon could be positive or negative. The only condition that we have is epsilon greater than delta. Now 3 by 2 plus delta minus 2 to the 4 plus y minus 1, I beg your 3 by 2 plus epsilon minus 1 to the 4 is equal to delta minus half to the 4 plus epsilon plus half to the 4, which is equal to half to the 4 plus half to the 4 plus epsilon to the 4 plus delta to the 4 plus epsilon minus delta. Now this epsilon to the 4 is greater than 0, delta to the power 4 is greater than 0, and epsilon minus delta is also greater than 0 from this. So this is greater than equal to half to the 4 plus half to the 4, and we know that the equality is attained at 3 by 2 comma 3 by 2. So 1 by 8 is the minimum value that can be attained. C is the correct answer. Now let us move on to the next problem. The next problem is a matrix problem. It says M equal to x, y, z be an orthogonal matrix with x, y, z belong to R cube as its column vectors. Then a new matrix is defined Q, which is x, x transpose plus y, y transpose. The given options are: it is a skew symmetric matrix, it's a 3 cross 3 identity, it satisfies q square equal to q, and it satisfies qz equal to z. So now since M is orthogonal, we have x, y, z, x transpose, y transpose, z transpose equal to identity, which implies x transpose plus y transpose plus z transpose is equal to identity, or q plus z transpose is equal to identity, which implies q equal to identity minus z transpose. Now Z transpose is a symmetric matrix, as Z transpose, the entire thing transposed, is equal to Z transpose. It is symmetric, so identity minus a symmetric matrix is also symmetric, because the sum of two symmetric matrices are symmetric. So it is definitely not skew symmetric, and A is wrong. We can see that Z transpose can definitely be not 0 if Z is a non-zero column vector, and so 3 cross 3 identity matrix is also wrong. We have to check if Q square is equal to Q. Now I minus Z transpose whole square is equal to I square minus 2Z transpose plus Z transpose Z transpose. Here, what is Z transpose Z? Z transpose Z is equal to mod Z square, which is equal to 1 because Z is orthogonal. So this is I square minus Z transpose minus Z transpose plus Z transpose, as this thing in the middle vanishes, so one of them gets cancelled. We are left with I minus Z transpose, which is equal to Q. So Q square equal to Q is the correct answer, and C is our correct answer. Thank you.